Hello class and welcome to lesson 3.2b, applications of maximum and minimum values. So again, this is part of our review from grade 10 where we took a look at a quadratic and put it into a word problem and then answered some key questions. So let's take a look at the first example here, class. Let's just make sure my smartboard's not being funny with me again. There we go. Okay, so look at example 1. A ball is thrown upward from a balcony. Okay, the height of the ball, h in meters, after t seconds is given by this function, h at t equals negative 5t squared plus 15t plus 45. I will tell you the negative 5, guys, is close to negative 4.9, which is the acceleration due to gravity, which if you take physics, you'll learn a lot about that, okay? So you'll see either negative 4.9 or negative 5 rounded there quite often whenever we're talking about throwing of a ball or of an object. Okay, before I even read the questions that it asks for, I like to remember, hey guys, what form this is in. This is in standard form. And what information does it tell us? Reminder, guys, that the c is the y-intercept. C equals 45. What does that mean? That's the initial height of the ball before it was thrown. So basically, the balcony has a height of 45 meters. So that's just before we start. We're going to always give our information that's given to us because quite often it's one of the questions that's asked either initially or later on. So let's take a look at question A. Question A, determine the maximum height of the balcony. So just remember, guys, for question A, in order to have maximum height, we need to either have the vertex or we need the y part of the vertex or your optimal value. And in order to do that, ladies and gentlemen, what do we need to do? We need to complete the square. Okay, so let's do that. We rewrite our function h at t equals negative 5t squared plus 15t plus 45. Okay. Taking a look, ladies and gentlemen, we're going to factor the a out of the first two terms. So that's going to equal negative 5 bracket t squared, watch your sign here, minus 3t plus 45. And again, we leave the 45 out because it's not going to be part of our perfect square. Then in the side margin, ladies and gentlemen, we're going to do our b divided by 2 business and then our b divided by 2 and square it. So b divided by 2 is going to be negative 3 over 2. Okay, and then you take negative 3 over 2 and you square it. It's going to equal 9 over 4. So that's the value that you're going to add and subtract into your bracket in order to get partially there in terms of completing our square. So again, you add 9/4 and subtract 9/4. Okay. Remembering, ladies and gentlemen, that the first 3 terms are what makes the completing of the square. So we need to isolate that next one. Okay. So basically, this is what we're going to use to complete the square. However, we have to deal with this negative 9/4. And in order to get the negative 9/4, it's got to be multiplied by the negative 5. So it's going to be positive 45 over 4. Okay, and to be consistent, ladies and gentlemen, how do we transform 45, which is 45 over 1, into a value over 4? You take 45, multiply it by 4, and you're going to get 180. All right. Now we can actually complete the square. So we've got negative 5, and we're going to go t minus 3 over 2 squared. And then we add these together is plus 225 over 4. So folks, our vertex in this case is 3 over 2, comma 225 over 4. So 3 over 2 is the time it takes to reach the maximum height, and the maximum height actually is 25 over 4. But does it make sense if we're talking about time to leave it at the fraction as 25 over 4? No, you may want to change your vertex, in this case, to a decimal. So the vertex is going to be 1.5. And if you use your calculator, you're going to get 56.25. Okay. So therefore, just 1 second, I get rid of that line, hopefully. Maybe it's going to cooperate. Let me just move back and come back. All right, still wants to stay with us. All right, so let's just finish that question off. So therefore, max height of ball is 56.25 meters. And if you're wondering when it occurs, at 1.5 seconds. Okay? All right. Which in fact, ladies and gentlemen, if you go to take a look at question B, B says, how long does it take the ball to reach its maximum height? We just answered it there. It's the first part of your vertex. So it takes 1.5 seconds for a ball to reach maximum height. All right. And ladies and gentlemen, the third question, or C part. C part says, how high is the balcony? Well, guess what? That's already been given in our question. We just had to spot it out. We know that it's 45 meters because it's the y-intercept, or the C value that was given in standard form. So that was given. Okay. Any questions about that first example, please come see me. Again, if you need to get the maximum height, complete the square. And B part was part of the vertex, so that also was completing the square. But you also could have found it if you had factored form. You could have just found two symmetry points, added them up and divided by 2. That's another way to get example B done. And C, again, you need to have it in standard form to find the y-intercept, or sub in x equals 0, and you would still get that answer. Okay? All right. Apologize for that interruption. Example 2. One number is 2 less than another number. Okay? Find the numbers if the sum of the squares is a minimum. So as soon as we see minimum or maximum, what does that tell us we need to do? We need to complete the square. Okay, so hopefully you spotted that out. You may just say, hey, but Mrs. R, there is no expression here that we can complete the square. Well, what we need to actually do is to create one. All right, so let's start with, first of all, a number. So one number. Let's let x represent, okay, the first number. Okay, and then it says the other number is 2 less than that number. So let's now, if I just use a different color here, is 2 less than another number. So we're going to let x minus 2 represent the second number. Everybody okay with that? So that's a little intro. Okay. If you're thinking about how that works, if you had two numbers, x minus 2 equal y, we're just going to let the y part represent that second number. Because again, we want to have one variable. We don't want to use 2. All right. Now it says find the numbers if the sum, what does sum mean to do, guys? Add. And you got to add the sum of the squares. Okay? So what we're going to do, ladies and gentlemen, is we are going to start with a function. So f at x equals the first number squared, okay, plus the second number squared. So again, guys, that is the sum, meaning add, of the two numbers squared. Okay? So all we need to do, folks, is to realize before we can complete the square as it is, we need to combine these terms. So we're going to have to expand it out first. So that's going to be our next step. So we're going to go x squared, that's that one, plus Now we're going to expand this out. So x square the first, double the product, and square the last. Okay, collect like terms. So we're going to have 2x squared minus 4x plus 4. Now we complete the square. Okay, so now complete the square. All right, so what we need to do first is remove a, or factor out a from the first two terms. So you're going to have x squared minus 2x plus 4. Do your margin work. So you're going to have negative 2 divided by 2, which equals negative 1. And then you take negative 1 and you square it. That equals 1. That's the number we're going to add and subtract to this inside the bracket. Okay, so we're going to go plus 1, minus 1. Okay, let's remove that third term, leave the first three terms in and remove the fourth term, which is that negative 1 out. Just remember it's affected by the a, which is negative 2, or sorry, which is 2, so this becomes negative 2 plus 4. Okay, and now we can complete the square. So it's going to be x minus 1 squared plus 2. Okay, taking a look, ladies and gentlemen, our vertex from here, okay, is in fact 1 and 2. And we need to double check because it asks for a minimum. Looking at a is greater than 0, therefore it opens up, which means we will have a minimum. That's another check to make sure you've got. Okay, and what we need to remember is that x is our first part here, so x is the first number. Okay, so we know that the first number is 1, so x equals 1, and then to sub in our second term, x minus 2 equals 1 minus 2, so you sub that in, which equals negative 1. So therefore, our two numbers that create a minimum are 1 and negative 1. All right. Please be careful. Don't say plus or minus 1 because they're both there in that case. All right, let's move on to the third example, and it's usually the harder one, so we'll take some time, make sure we understand how to do this. This is one of those field questions where you've got to maximize the area. All right, the key here, guys, is to read the question and create a drawing to help you understand that. All right, so taking a look, a field is to be enclosed and divided into 2 equal sections. That means it's not going to be a regular rectangle, which we would optimize to a square, so it's going to be a little different. And again, you look for the amount of fencing, 3,500 meters. What does that tell us? P equals 3,500 meters. That's our perimeter of fencing. So what dimensions will maximize the area of the field? So first of all, it says we have to draw a field, okay? And then we're going to put it into 2 equal sections. And it's always easiest, guys, if you divide your width instead of your length. It's easier. So what do we really have here, guys? We have 1, 2, 3 widths. And how many lengths would we have? 2 lengths, right? So if we're doing our perimeter formula, perimeter equals 2 lengths plus 3 widths. Everybody okay with that? Let's sub in what our perimeter is. So our perimeter is 3,500 equals 2 lengths plus 3 widths. And remember, we want to include in our diagram just one variable. So we're going to leave the w's as is, and we're going to use this formula here, guys, to rearrange this for L and to put L onto our diagram in terms of its width. So we're going to get this 2L term by itself. So it's going to be 3,500 subtract 3W equals 2L. Okay, and to get L by itself, divide everything by 2. So L equals 1750, subtract 3 over 2W. So that's what I'm going to add onto my diagram. So instead of doing my length, this whole measurement is going to represent 1750, subtract 3 over 2W. Same on the bottom. And you might say, hey, Mazar, that's great, but why did we do that? Because we need to have those measurements in terms of one variable so that we can do question A, which is what dimensions will maximize the area. So we needed to have those dimensions in order to do area. Just remember, area equals length times width, but area in terms of its reference to width is going to equal length times width, or you might like to do width times length. Okay, and when we sub this in, we know width is W, but our length is 1750, subtract 3 over 2, W. All right, I'll just move that over so you know that's just a bit of a margin there. Now that we've got our expression in terms of area, it says we need to maximize the area. In order to maximize, what does that mean to do, guys? So if it says to maximize the area, we need to complete the square. Okay? Before we can do that, let's expand this out so we can get our W values in a better fashion. Okay, so we're going to have 1750W subtract 3 over 2W squared. Just putting it into standard form, ladies and gentlemen, it's going to be negative 3 over 2W squared plus 1750W. All right. Okay. Now we're going to take a look at completing the square. And this one's kind of tricky because, yes, it has fractions, but we can do this. Okay, I have no problem with that. Okay, so here we go. Just going to move this up if I can. Definitely going to need to have some more room here, so just give me a second. All right, so first step when we complete the square is to factor out A out of the first two terms. In this case, there is no third term, and that's okay. We don't have to worry about it. Okay, so we're still going to follow the same process. So when you factor that out, you're going to have W squared minus, let's see, 3,500 over 3 W. Okay? Everybody okay with that? Just double checking here. Yeah, I think we're on the right track. If I factor that out. Okay. All right, now what we need to do, folks, is take our middle term, okay, which is B, got to divide it by 2, okay. If you're wondering where this came from, folks, okay, it is 17, I'm just double checking my notes here. So it's 1750 divided by negative 3 over 2, as I wrote that incorrectly, okay. So 1750 divided by 3 over 2, because you got to divide it by A, okay. That really equals 1750, and you invert that fraction times negative 2/3, okay, which is going to give you the negative 3,500 divided by 3. So just further explaining where that came from. All right, okay, hopefully we're good with that, so you understand how we divided that through. Now we're going to take a look at doing our B divided by 2, and this is a tricky one in this case as well. So let's take a look. So B in this case is negative 3,500 thirds, and then we're going to divide that by 2, which is really 2 over 1. Okay, so if you want to do the long form, it's 3,500 divided by 3 times 1 over 2, because you got to invert and flip that second fraction, which is going to be negative 3,500 over 6. Okay, then we can put that into lowest terms, ladies and gentlemen, which is negative 1750 divided by 3. So that's B divided by 2. Now what we need to do is B divided by 2, got to take it in, you got to square it, which will equal negative 1750 divided by 3 all squared, which is a big fancy number. Get ready for this. You ready? 3,062,500 all over 9. Is it math fun? Woohoo! That's the number that we're going to add and subtract up above here. Okay, so again, timing is always, or spacing is always an issue in a class. I'm not sure how much room we're going to need. All right, so I'm just going to move this over because we've got some big numbers coming in. So we've got W squared minus 3,500 over 3W. Now we're going to add and subtract this value, okay? So we're going to add the 3,062,500 all divided by 9. And then we're going to subtract the 3,062,500 all over 9. Okay. Again, we only need the first 3 terms to complete the square. So we're going to use that. So write our 3 terms out. And remember, guys, when you take this fourth term out, you got to multiply it by a. Okay, and when you bring it out, it's going to be plus 3,062,500 all divided by 6. Okay, because you can cross out some of you cancel out the 3 and the 9, or just use your calculator with the fraction button is probably the easiest. All right, let's finish this off. So let's complete this square. So we've got W minus 1750 divided by 3 all squared plus, you can reduce this to lowest terms, 1,531,250 all divided by 3. And you're going to say, yes, Mrs. R, we got our vertex now, but that doesn't make a context to our maximum area. So now that you've completed it, now change your vertex into fractions, because if you do fractions too early in the problem, ladies and gentlemen, you're going to reduce the accuracy. So let's take a look. It's going to be 583.3, which is your x coordinate, your vertex, and your y coordinate is 510,416.7. Just remember, guys, when you have a fencing question, this is the width, which is your x component, and this is your maximum area. All right. So it says, what dimensions will maximize the area? It didn't ask for maximum area. So what do we already know? We already know that width equals 583.3 meters. Okay. But to find the length, remember, length equals 1750. My fault. If we go back up to that first statement we did where we subbed it in to the board or into our diagram. So sub in 583.30 there, and you're going to get the length equaling 875.05 meters. So therefore, dimensions to max area are 853.3 meters by 875.05 meters. Okay? And the very last question, which, ladies and gentlemen, we've already done the work for, we just have to state the answer, is part B, saying what is the maximum area? So B, max area is 510,416.7 meters squared. Don't forget your units there, guys, for maximum area. All right, folks, so today you're going to have a handout. If you forgot to hand out, then check my website, and I should have it posted down there saying 3.2B handout or min-max handout. I can't remember how I labeled it on my website. Anyway, good luck with that, ladies and gentlemen, and be careful here. Only do 3, 4, 7 to 11, and the answers should be posted there to make sure you're in the right direction. Thank you, and have a great day, guys. And again, come see me in class or see me if you need any extra help. Bye.